In this video, we'll discuss how to solve quadratic equations. The first thing we want to do is always put our quadratic equations into general form, where it goes from x squared to x to the constant. So ax squared plus bx plus c equals 0. This allows us to use our different forms of solving the equations correctly to get the solutions. So if I had an example where I needed to write 9 minus 2x equals 3x squared in general form, I have two options. I can either subtract 3x squared from both sides so that all the terms are on the left-hand side and then rewrite it in the order x squared x and then the constant, or I can move over the 9 minus 2x to the right-hand side. I'm going to do the latter because it maintains a positive x squared, which is a little bit easier to work with. So first thing I would do, since I wanted to go x squared and then x, I would add 2x to both sides. This will leave me with 9 equals 3x squared plus 2x. Then I subtract the 9 from both sides, so that in general form, this is 0 equals 3x squared plus 2x minus 9. Now you may ask yourself, what does solving even mean for these quadratic equations? What is happening is that we're really looking at where does the graph of the equation cross the x-axis. So in other words, we're looking at when does the y value equal 0 for this graph. So if we look at the equation x squared plus x minus 6 equals 0, if we're trying to understand what this means, we would graph y equals x squared plus x minus 6, and it would create this parabola. And then what we're looking at is saying where does the y value equal 0? And it happens wherever we cross the x-axis. So in this case, that is at negative 3, 0 and at 2, 0. That means that the solutions for this equation are x equals negative 3 or x equals 2. Now graphing is a great way to double check ourselves and make sure we understand what the meaning is, but we can also use factoring as well as the quadratic formula to help us solve quadratic equations if we don't have a graphing calculator handy. So the first thing we do if we're going to factor is write the equation in general form. Then we can use our group factoring methods to factor that quadratic expression. We can then take each expression, set it equal to 0, and solve for the variable. And you should always verify your solutions to make sure that they do work with the given quadratic equation, as well as to make sure you didn't make some mistake along the way. So say we had x squared minus 15 equals 2x, and we want to solve that equation. First thing, let's subtract 2x from both sides so that we're in the general form. And remember, the 2x needs to be in the middle so that we can keep that descending form for the variables. So this becomes minus the 2x will become x squared minus 2x minus 15. Now I can factor this using group factoring and say, what are my factors of negative 15 that sum to negative 2? Often when I think about 15, I think about 5 and 3. And since I want this to be a negative 2, I know the negative 5 would need to be greater. So negative 5 times 3 is negative 15, and negative 5 plus 3 is negative 2. So those would be my two factors. Now if I'm group factoring, I replace my middle term with those two terms, minus 5x and plus 3x. And if I think about that, those two are negative 2x when combined. Now I can group factor and say if I look at my first two, I can factor out an x. If I look at my second two, I can factor out the positive 3. And that leaves me with x minus 5 in the remaining factored components. So I know I've done my factoring correct. Therefore, I have the factors of x minus 5 and x plus 3 equals 0. So I have it factored. Now I take each of those factors and set them equal to 0. So x minus 5 equals 0. I add 5 to both sides. Now give me x equals 5. If I have x plus 3 equals 0, I subtract 3 from both sides to get x equals negative 3. Now I want to verify them by substituting back in 5 and then substituting back in negative 3. So 5 squared minus 15 equals 2 times 5. That'd give me 25 minus 15 equals 10. If I do 25 minus 15, that is 10, so that solution does work. Now let's do that with a negative 3. I have negative 3 squared minus 15 equals 2 times negative 3. Remember that that is negative 3 times negative 3, which is positive 9. 9 minus 15 is negative 6. So again, this solution works. Then that verifies for me that the two solutions are x equals 5 or x equals negative 3. Now the other method I mentioned earlier was the quadratic formula. You can use that with any quadratic equation, and we often use it when we can't determine those factors, especially if it can't be factored with integer values. When we do this, we again need it in the quadratic form. So in that general form of ax squared plus bx plus c, because we're going to use those values for a, b, and c into the quadratic formula. So the quadratic formula is x equals, and then in our numerator, negative 2 plus or minus the square root of b squared minus 4 times a times c all over 2a. And those a, b, and c are just the coefficients, just the numbers. There are no variables that we put into this formula, just numbers. And this plus or minus is how we get our two solutions, because we will do one with it plus and one with it minus. Now, if our radical is not a perfect square root, we need to simplify it. We keep our fraction in fraction form unless a problem asks us to round it to a certain decimal point. As always, we should verify our solutions. And if it has a radical in it, the easiest way is to let's look at the graph. So let's say we go back to the problem that we already turned into a quadratic equation in general form, which was the 3x squared plus 2x minus 9 equals 0. So let's go in and use the quadratic formula here to understand what's going on. So if I have it in my general form, I'll look at this and say my a value is 3, my b value is 2, and my c value is negative 9 because of that minus 9. Now I can substitute those values into my quadratic formula. So it's the opposite of b, so that's negative 2, plus or minus the b value squared, 2 squared, minus 4 times my a value of 3 times my c value of negative 9, all over 2 times my a value of 3. I start to do my simplification, and always pay attention to those negatives. If I do that, 2 squared is 4. Negative 4 times positive 3 times negative 9, because there's two negatives, that becomes plus 108. And then 2 times 3 is 6. When I simplify inside the radical, I have 112. 112 is not a perfect radical, so I need to simplify that radical, and I'm going to use my tree factoring to help me. I think about 112, I can split that into 4 times 28. And again, you could start anywhere. I started with 4 times 28. Then, if I look at 28, I'm going to split that into 4 times 7. I didn't split the 4s because 4s are perfect squares as it is. But I can also then look and say I've got 2 of them. So I have 2 4s. So square root of 4 times 4, or square root of 16, is 4. And then I'm left with 7 inside my radical. My last thing when I look at that radical is I say, can I simplify the 2, the 4, and the 6? Because they're all outside the radical of my fraction. And yes, I can divide them all by 2. This will become negative 1 plus or minus 2 to the square root of 7 over 3. That is my solution, because it could be plus 2 to the square root of 7 or minus 2 to the square root of 7. Now, the next part to that is checking, what does that mean? Well, if I put this in a calculator and get the decimal value, I'll get approximately 1 and 431 thousandths and negative 2 and 97 thousandths. Those are the approximations. So let's graph this equation and see what does this look like as a quadratic equation on the graph, and see where it crosses the x-axis. And when I do that, I'm going to check those x-intercepts, and I will see that it crosses here at negative 2 and 97 thousandths, and here at 1 and 431 thousandths, which is exactly what I wanted.